I have an exercise for you. We will be doing some debugging in this lecture. To get started off with, we have a struct vector2d. Okay, so I just want you to look at the code that we have, and then I want you to fix it so that it will provide the output that we would expect, because if we build and run this now, it will actually not produce that. Okay, so we have this vector2d. It has a constructor and a destructor. The destructors we can actually leave out here. I just added them here for completeness, but they actually won't be doing anything for this lecture here. So in the constructor, for the vector2d struct, that is simply going to initialize the members x and y, which are doubles. It actually has default arguments here as well. So the parameter for x is initialized to 0, for y it is initialized to 0, and we use the initialization list to initialize those. Then we have the player stats class, as we have seen in previous examples. This also has a constructor with some default arguments. We set the health, which down here we have health, and the vector2d for location, to keep track of one of our players' locations in the world, just as a silly example. So here we have the health, which also has a default argument. Then for the vector location, let's say for some reason I want a default argument for that as well, so this is how I have it set up currently. And then in the initialization list, I go and initialize it in this way. I also have a getHealth, a member function, and also a getPosition. So this will actually return the location. It's going to return a vector2d. Alright, and in the main function, I do two instantiations here, player1, and then I do player1.getHealth. So notice that I'm using the default construction. And then in the second line, I'm going to do get POS for get position x and y. So what do we expect to have happen when we instantiate player1? Well, it's going to use this constructor. So by default, we should be setting our health to 100 and the vector location to some value. I'm just using 3 here and 4, 7, something like that. Or you can set it to 0 as well if you want. Then I'm doing another instantiation for player2. And then I'm doing player2.getHealth. In this example, let's modify the health. So the health should be initialized to 75. And so I pass in these values to construct the location. And then I do player2.getHealth, and then I do the getPosition again. So we should get these values printed out, 3, 3, 4, 7, and then these values here as well. If I build and run, notice that we get the health. That seems to be correct, 175. We have modified the health. We passed in 75 in the second construction, but notice that the values for the location is incorrect. We actually get 47 and 66, which, if you will notice, 66 here is passed in for y, and here the default construction 47 is also for y, so we are missing this value right here. Okay, so I'd like you to take a bit of a break here, pause the video and attempt to fix this code. At least think about what you would do to get this code to build and run and produce the output that we would expect from this. Again, we want these values to print out for the location, and then also the default values, which again is here. We want those to print out by default. Of course, when you attempt this exercise, you do not have to use this exact code. You can use a toString function for the player stats to get the x and y. But here I'm just using this syntax again, player2 getPosition and x. Okay, so we have sequential execution of our code, so that is how I will go about solving this problem. We start with this instantiation, and when we get the position, so getHealth works, but if we get the position, that doesn't work as we would expect. And that's because something is wrong here with our constructor. And so you have to think about how we create a literal or temporary of a custom type. This is not helpful. Okay, so we are assigning this to vector2d. What we are doing here is we are using the comma operator, and so it's going to discard the left-hand operand and it's going to assign the right-hand operand. And it's basically going to assign that to the first member, which of course is x. So that is why we don't get the value that we would expect. And so with that, we need to construct a temporary value, as we can see here with int health 100. How do we do that for vector? Well, we do vector2d, And we'll use the braces instead of parentheses for the initialization. So we are creating a temporary object, so a literal, as we can see with the integer here. Okay, so that's basically the same thing, and we are assigning that to the location parameter. And we can do a similar thing if we scroll down. Again, you can think for a second with the second instantiation. What are we doing here? Well, again, we want to instantiate, or should I say create a temporary object. This is going to give us the same issues that I explained before. We have the comma operator, and that is going to essentially ignore the left-hand operand, and it's going to use the right-hand operand. Eventually, the right-hand operand will get assigned to the member X for the location. So that is not what we want. We actually want to construct a temporary vector 2D, and that will get passed in here to the vector to the location. Okay, so it'll use that instead of the default argument. So again, we want vector 2D. If we build and run now, the values that we would expect are actually now printed out to the console. Alright, so hopefully this is easy for you to understand at this point. I took a bit of time to go over this because this can get you confused. So we really have to think about how do we construct a temporary or a literal value of a custom type, a struct or a class. And then we also need to take into consideration the comma operator that I discussed in the previous lecture. Typically, I do not construct or have default arguments in this way, but again, I just wanted to demonstrate that just in case you decide you want to do that or you see that somewhere else. And then here where we want to pass that in as an argument, again, we want to construct or instantiate an actual object in this way. We don't want to pass in some random values, use the comma operator and expect the compiler to figure out what's going on. We want to pass in an object. And as I've discussed in previous lectures, it's even better to instantiate that and assign that to a variable. So in this case, let's say we have player2 location or something like that, some variable like that, and then pass that identifier into here. So if you did it in that way, then congratulations, that's actually the better way of doing that. One final example on this, in the main function, in this example, I have these integers, int j initialized to 3, k initialized to 5, and l initialized to 7. Then I go ahead and print those out so that we can see what those are before we modify those. But in this next statement, I initialize this variable m to this right here. J is equal to k, so we assign whatever is stored in k to the variable j. And then we have L here. We have the comma operator and then we have L. Alright, and then we print those out just so we can see what we're actually doing over here. Then I go ahead and print all of those variables out. You may want to pause the video for a second and think about what we are going to print out with these values and basically what we are doing here. Alright, I will build and run and we can see that we get j is 3, k is 5, l is 7. That is what we have those initialized to. Then we go ahead and we do this statement. We declare and initialize the variable m. So we initialize m to whatever this expression is going to return. We can see that we have the comma operator here. To the left of that, the left-hand operand of that is this expression j, the assignment operator and k. And then we have l. The comma operator again is going to evaluate the expression to the left, so it's left-hand operand. It's going to discard that result and then it's going to return the result of the expression or operand that is to its right, so in other words the right-hand operand. So in this case L, the value stored in L, in this case 7, will be used to initialize the variable m. So we have j is now 5 because again we assign k to j. The variable k is going to remain at 5 and then l is going to be 7 and then of course m is going to be 7 as I mentioned. So that is going to wrap up this lecture on the comma operator. I just wanted to mention this because it can confuse you in some instances where you use it to do initializations and stuff like that. So again, the comma operator will evaluate the left-hand operand. In this case it's actually an expression, and then it's going to basically ignore that. And then it's going to evaluate the right-hand operand. In this case, we simply have L here, but this can also be an expression that it evaluates, and it's going to return that value. In this case, the value that it returns is going to be used to assign or to initialize m. Alright, so with that, we are going to wrap up this lecture.